Good afternoon, doctor. We are from Group 1 Innovator. Next, for this project, we chose dataset about obesity level and lifestyle. Next, we are going to investigate the factors affect BMI level, which are gender, age, height, weight, frequency of consumption of vegetable, FCVC, number of men-meal, NCP, physical activity frequency, FAF, transportation use, M-trans, and NOBS, dead obesity level. Next, first, we apply hypothesis to sample test. We are going to test on difference in mean BMI level between males and females. We assume for this test, unequal variance is used and significant level alpha equal to 0.05 is used. For this hypothesis test, the null hypothesis has not, which is mu1 equal to mu2. Alternative hypothesis has 1 is mu1 not equal to mu2. By using RStudio, we obtain the degree of freedom, which is 1823, and the test statistic is negative 2.428. For the p-value is equal to 0.008, which is less than significant level equal to 0.05. The conclusion of this test is there is sufficient evidence at significant level of 0.05 to conclude that there is a difference in mean BMI level between males and females. So we can make a conclusion that different gender have different BMI level.
Yeah, so now I will explain about the correlation test. And as a correlation test, we have test the relationship between the age, frequency of consumption of vegetable, FCVC, number of men meals, NCP, physical activity frequency, FAF, and also the BMI level. And the sample size is Q111. And from the heat map and also the table, we can observe that the top three higher value in the correlation tab is the BNI with S, BNI with SCVC, and also the BNI with FAF. And next. So in here, we go more detail, which is the relationship between the physical activity frequency FAF with the BNI level. So from the staggered plot, we can observe that this is a negative relationship. And the hypothesis statement, the null hypothesis we made it is P equal to 0, which is there is not a linear relationship. And the alternative hypothesis is the linear relationship exists. So in here, the significant level we use 0.05. And so that by using the RStudio, we get that the correlation coefficient is negative 0.177. And the test scarcity is negative 8.28. And the degree of freedom DF, we take a Q109. So that in here, the p-value we get 2.2 times 10 high, negative 16. So as a conclusion, because the p-value is less than 0.05, so we will reject the null hypothesis, which has 0. And the negative correlation showed a weak relationship between the BNI and also the FAF. So there is, because it is no more than 0.8, so it is a weak relationship between them.
Okay, for the correlation, for the regression test, we test the relationship between the weight and the BMI levels of individual with sample size of 2111. Okay, for this test, the independent variable X is weight and the dependent variable Y is BMI levels. So from the scatter plot, we can see there's a positive linear relationship between the weight and the BMI level, which indicate that when the weight increase, the BMI level also increase. So the the straight line inclined upward indicate that the positive linear relationship. Okay. For the more detailed hypothesis test, okay, we test the linear relationship between the dependent and independent variables. So the null hypothesis is that there's no linear relationship, and for the alternative hypothesis, linear relationship does exist between the independent variable and the dependent variable. So for this test, we use significant levels of 0.05. And okay, we can see the summary obtained from RStudio. From the summary, we get the p-value 2.2 times 10 to the power of -16, and is smaller than the significant level, which is 0.05. Thus, the null hypothesis is rejected. So there's sufficient evidence to show that there exists a linear relationship between the weight and the BMI levels of individuals in the samples. So from the scatter plot just now and the summary, the R2 is 0.8739, which is very near to 1. So it indicates there's a very strong linear relationship between the independent variable weight and the dependent variable BMI level. So in conclusion, the BMI level of an individual is dependent on the weight of the individual. Okay, so next, we also carry out ANOVA tests. So okay, for ANOVA tests, we carry out to analyze the significant difference between the means of the BMI levels of individuals who use 5 different types of transportation methods, which are public transportation, automobile, walking, motorbike, and bike. Okay, for more detailed tests, the null hypothesis for our hypothesis test is all the mean BMI level which use all types of the transportation method are the same. While for the alternative hypothesis, there's at least one mean is different. Okay, so for this test, we use 0.05 level of significance. And now from the summary obtained from the RStudio, okay, we get a p-value that's 9.95 times 10 power of -9. That's smaller than significant level 0.05. Thus, the null hypothesis, which is the means of the BMI levels of the individual using different types of transportation are same, is rejected. So there's sufficient evidence to show that the individual of at least one types of transportation methods have different BMI, mean BMI levels with the others. So in conclusion, the BMI levels of an individual is affected by the transportation method the individual use.
Next is the chi-square test of independence. We have conducted a chi-square test of independence to determine whether there is a significant relationship between gender and obesity levels. This is the hypothesis that we have created. The null hypothesis H0 is the obesity levels are independent of whether the gender of the person is a male or a female. And the alternative hypothesis H1 is the obesity levels are dependent on whether the gender of the person is a male or a female. For this test, we use a significance level of 0.05. Alpha equals to 0.05 is used for this test. And then we create a two-way contingency table for the observed frequency and also the expected frequency. Next. This is the summary obtained from RStudio. From the summary obtained, the p-value is less than alpha, which is 2.2 times 10 to the power of -16 is less than 0.05. Thus, the null hypothesis is rejected. There is sufficient evidence to support the claims that the obesity levels are dependent on whether a person is a male or a female. Hence, we can conclude that the obesity levels is highly dependent on the person's gender. This is because male has higher BMI compared to females, simultaneously increasing their chance of being overweight. That is all from us. Thank you.